You're listening to Masonry Principles, your guide to building better buildings, with hosts Amanda Bedian and Phil Leden. Welcome to Masonry Principles. Today, we've got Christine Subasic, but we know her as Tina. She is a consulting architectural engineer specializing in masonry and sustainable design. Welcome, Tina.
Thanks, Amanda. Good to be with you.
Yes, and we also have Phil on. Obviously, he's our other host. How you doing, Phil?
Good, good. Thanks, Amanda. Really excited to talk to Tina this morning.
We're so excited. Tina has a wealth of knowledge when it comes to sustainability in masonry. So we've got a few questions for her, and I just wanted to touch base on if you were familiar with the 2030 commitment through the AIA, Tina.
Yeah, that program has evolved from an initial challenge that went out by AIA, American Institute of Architects, many years ago, and has kind of evolved into that 2030 commitment. And it's really got to focus on obviously climate change and carbon neutral and things that the building community can do to hopefully affect real change in our environment.
Yeah, so I mean, I think it's really interesting. And if you're not familiar with the 2030 commitment through AIA, it's all new buildings, developments, and major renovations shall be carbon neutral by 2030. Currently, there's 784 total firms in the US that have signed on to the commitment. Me representing New York and then Phil representing Michigan, I pulled those numbers. We have 102 firms that have signed on in New York, and there's 16 firms in Michigan. And then obviously the numbers continue to grow. And I think it's just a really interesting, it's an interesting challenge to see who's involved and who's not. And you can go to the AIA.org website and pull out if you're interested in what firms have signed on to the challenge and what it, dive in a little deeper. Again, I would check out AIA.org. But to get things started, I know, Phil, you have, we were talking like when it comes to sustainability, I feel like it's more on the architecture side than it is the engineering side, correct?
That's absolutely right. So, yeah, when I worked in engineering, I mean, I just wasn't really exposed to a lot of these issues. And I think holistically, it's everyone's responsibility. And maybe that's bad on the industry for putting it on the architect for so long. But yeah, I mean, it's really good to hear from someone like Tina. And so, Tina, I guess some of the things I've heard about a lot this year deal with carbon sequestration. And so, I guess I'm just wondering how has the masonry industry impacted the view of masonry as a sustainable material relative to carbon sequestration?
Yeah, well, so carbon's certainly been in the news a lot. There's a lot of conversations about it. And I guess to kind of lay a few definitions down, if you will, or kind of get a common understanding. So, carbon sequestration often refers to, or generally refers to, taking carbon that is in the air and sequestering it or storing it or capturing it in some fashion, either in a material or in the ground or through some other processes, converting it. And so that is one thing that is out there in terms of technologies being developed to capture existing carbon and deal with it. How do we store it and get it out of the air? The other aspect, though, that you're hearing a lot about recently is embodied carbon, which may be a little bit more directly related, Phil, to masonry materials, because embodied carbon refers to the carbon equivalents that are created during the manufacturing process of a building product or any product for that matter, but of a building product. And so when we talk about embodied carbon, we're talking typically about the energy used to create something. And so different products have different amounts of embodied carbon, but it's really looking at just that initial construction phase, if you will, or the manufacturing phase of a product. But it doesn't look at the life cycle. And that is one of the shortcomings of focusing on embodied carbon in building products because it is really just that snapshot in time. And it doesn't look at what happens at a building over its lifetime in terms of operations, in terms of maintenance, and other things. But with regard to masonry and embodied carbon, there's a little bit of awareness of it with regard to masonry, but I would say so far the focus has been on a lot of the other bigger structural materials like concrete, for example. You hear a lot about the cement and the embodied carbon, or the carbon footprint of cement in general, cast in place concrete, that sort of thing. And so, with regard to masonry, obviously we use cementitious materials, and so it is there. I will say generally, we're pretty efficient in the use of the cement we use, but really the scrutiny hasn't come down to the level of masonry. But it is important that as an industry, we're looking at that and our carbon footprint, if you will, of our products.
So, in terms of, I guess, embodied energy or embodied carbon, as we look at a building's service life, I mean, we're going to be pretty constant from a masonry or really a concrete perspective, just because those materials tend to have a longer life expectancy. I would imagine that's kind of what you're alluding to with masonry having an advantage, because for wood or for other building materials, I'd expect that would have kind of a variable embodied carbon or energy that would increase over time. Is that right?
Yeah, so it's interesting when you think about structural materials. Obviously, most structural materials don't require a lot of maintenance, but when you start looking at the building as a system and what else is required in terms of maintaining that as a system, that's where things can come into play. So, for example, if you just think about, we'll take a school, which is a common place you might find masonry construction, load bearing masonry on the interior, not just for the exterior, of the buildings versus a building framed with steel stud walls and gypsum board sheathing on it. Well, that gypsum board isn't going to last over the lifetime of a school building. Obviously, it's going to get damaged, it's going to need painted, it's going to need replaced, those kinds of things. And a lot of times you hear people talking about in body carbon, they're looking at just one element and not as the building as a system over the lifetime. So that's one aspect. You can't just say, oh, it's wood or steel framed. Well, what about what has to go on that? Finishes and those kind of things I think are often overlooked. But then the other thing with regard to operation is just even thinking bigger picture. When you think of the building as a whole, I had a colleague share a story about a seminar she heard at Greenbuild. And so this isn't first hand knowledge. I didn't attend the session, but she attended the session. She was saying there was a conversation about the embodied carbon of a building. And when you look at a building operationally, when they have to replace the refrigerants and the HVAC systems, that emits more carbon to the atmosphere than the total of the building products in the project over the lifespan of the building, or it can, right? So emissions of actual carbon dioxide and other greenhouse type gases can be as much of an issue when you look at building systems and HVAC systems and other things as much as the building products. So we tend to focus on building products because that's what the industry kind of, has a focus on. It's a quick and easy thing to look at, but I think it is another area where it's really important to have a whole building and a whole life cycle approach to looking at things. So, not that we shouldn't look at embodied carbon in our building products. I think that is important, and we all have our part to play, right, in reducing the potential effects on the atmosphere and so forth. But it is also important to look not just at the first thing that comes to mind, but to look at the entire building and the operation and all the systems that go in it.
That's a really good point. So since the industry does just kind of focus on embodied carbon, since it is such an easy metric, I guess in future building codes or the future of the industry, do you see that kind of evolving to look at things more holistically? Because what you just said made a ton of sense to me. I mean, why aren't we doing that? How can we move to a place where we focus on more than just maybe embodied carbon?
Yeah, it's a good question. So I think things are starting to evolve. As you mentioned, the 2030 challenge obviously has been around for a while because it's already 2020 and we're not quite anywhere near where we thought. I think I can't remember if it's more than 10 years old now. I think the challenge when it first came out. So this notion of looking at embodied carbon has been with us a while. And, I think we started with what's easy, which is, oh, building products, right? Like we can measure how much energy goes into them. And it's part of doing a life cycle assessment for a product. So I think that's part of where that's the easy part. We can measure that. It's a lot harder to measure and know what goes on during the operations of a building, how many replacements there are, how much energy is used in terms of operating the building and so forth. So it's a little harder to get at the data is one thing, but things are starting to evolve a bit. It's kind of a mixed bag. There's an increased focus on carbon just in general and an awareness because not only does AIA have their 2030 challenge, the Structural Engineers Institute, which is part of the American Society of Civil Engineers, actually just recently put out their 2050 challenge. So a similar kind of thing for structural engineers to be looking at embodied carbon. So there's an increased focus on that, but some of the good news from a whole bigger picture perspective is there's actually starting to be some more study by the folks that do life cycle assessments and whatnot, looking at, for example, life cycle assessment of wood, because up until just very recently, just really the last couple of years, most people were just accepting wood as a carbon neutral material, saying, it harvested and trees get replanted and therefore everything's just a wash. Well, the reality is that's not always the case, and it's especially not the case when you don't have a sustainably managed forest. And so there are a lot of impacts actually associated with the land use and disruption of the land and what gets planted back and how quickly trees can reabsorb carbon and all that. So to the point where a number of life cycle assessment experts and so forth are finally digging in and saying, we can't just give wood a pass. It's not just carbon neutral. Because as they start to look at this bigger picture, they recognize that no, in fact, there can be carbon associated effects with wood, and we need to look at this more closely. So, in that regard, things are starting to shift a little bit, but we still have a ways to go.
I think another advantage, I guess, when we compare maybe the masonry industry with the softwood lumber industry is that typically masonry is manufactured locally, close from a project, which does save on some of those transportation costs, things like that. I'm in Michigan, where we get a lot of our wood from Canada and other regions. So, how can we do a better job at promoting, I guess, some of those other sustainable aspects, such as the transportation and things like that?
That's a good point. I think it is important to focus on the benefits on the local economy and not and the environment as well. I mean, the one aspect of sustainability that often gets overlooked is the sustainability. We talk about it's a three-legged stool. It's the environment, it's economics, but it's also society and societal effects. And that is another aspect in terms of when you think about locally produced and manufactured materials that they're stimulating your local economy. They're providing jobs in the local economy and so forth. So, thinking about that not only from an environmental standpoint, from the transportation issues that you raised, but also from the economic and the societal aspects of sustainability in the local economy, I think is also important. So I think masonry does really well when we remember to look at the big picture and whether that's the big picture of sustainability being more than just environment, but also economics and societal benefits, or we talk about sustainability or being more than just environment and we think about durability and resilience and other aspects, right? Or we think about over the life cycle. It's really important that a lot of the benefits of masonry come from making sure we're taking in a really big picture view of things and taking into account a lot of stuff that gets overlooked when you just focus on one single attribute or aspect of concern.
Do you think that in the world of greenwashing, that if we shared, obviously, like you were talking, the big picture, that that would help them navigate through all the greenwashing that is happening in the construction community?
Yeah, I do think, and I guess, greenwashing is something like to characterize it. I don't know if it's as misrepresented maybe as it used to be years ago. Greenwashing was a huge issue, but I do think, Amanda, it is a good idea to combat those singular focused things with that bigger picture message because I was working on some presentation just recently about masonry and resilience. And, masonry is inherently resilient. It provides what I call kind of above code performance, just inherently because it's masonry, in terms of non-combustibility and being durable and impact resistant and so on. And those things go beyond what this singular focus or that kind of tunnel vision can kind of drill into. And so that's something that is important, I think, to keep in mind.
Completely. What do you think the stigma is against masonry when you're talking sustainability? Like, why do people not think of it as a sustainable product?
I think rightly so, folks look at the energy used when you think about it compared to wood, for example, right? It's manufactured and, brick are fired in a kiln. It takes a lot of energy. So, in terms of when you think of it compared to wood, that's one thing I think that comes up is people think it is an energy intensive thing as far as, being sustainable or not. And so, again, that goes back to that single focus. But, when you compare it to steel or concrete, I think masonry does well in terms of sustainable or looking at the energy metric in particular, it's not at a disadvantage. So I think with regard to sustainability, I think the energy and then the cement aspect of, having particularly for concrete masonry, cement and the embodied carbon is probably the thing we have most to work on, but a lot of manufacturers are combating that, right? They're doing things to introduce materials that they use supplementary cementitious materials, which are replacement materials for cement. So it lowers the embodied carbon of the product in that fashion. The other thing I think to think about with sustainability and with masonry is that you can design really efficiently, right? It's possible to be very efficient in the use of material. So that's another thing that I think we need to think about more. And as an industry, we need to make sure designers are not being overly conservative in design. I think about Phil, going back to the structural aspect, F prime M of 1500 psi is not the magic number, but that's the number that everybody uses, right? Particularly if you're of a certain age and you're doing work and that was just the assumed, that's the minimum value. What you really might get with availability from manufacturers can be dramatically more. And the relatively recent code changes also that reflect higher value. So, I think that's one thing that as an industry we need to do is also educate people on doing it efficiently and making the best use of the materials.
That's a good point. I've been pushing engineers in Michigan recently to use even unreinforced masonry because I mean we're not in an active seismic area. And in Michigan, it seems like bars at 48 inches on center are the norm, whether you're an interior partition wall or an exterior bearing wall. And in a
Mm.
lot of cases, I think that's kind of our biggest downfall is we do just over engineer it. It really hurts our industry.
As far as resources available to educate yourself in the sustainability with masonry, where would you point people to?
Oh, that's a good question. There's a lot of different resources out there. The Concrete Masonry Association, NCMA, BIA, which represents the brick industry, PCA, representing the cement industry. They all have publications on their websites that talk about masonry and sustainability. I know IMI and the number of the different regional groups, often have information. I've written a number of articles, whether that be in Smart Magazine or other places, as far as talking about lead or other aspects of sustainability. So I think the industry has a decent amount of information out there. The other place is TMS, of course, TMS being the Masonry Society. We published, the sustainability committee there published a brochure about masonry and sustainability a number of years ago that has been updated to lead version 4 at least. And more recently, there's a building performance committee that was established at TMS that is looking into a number of these broader issues beyond just sustainability into resilience and energy efficiency and so forth. And that committee is just getting going, so they don't have a work product for me to point to at this point in time, but I expect some good things to come out of there as well.
Fantastic. Now, what made you, I mean, trying to get to know you a little bit more, why did you pick sustainability as your topic of expertise?
Sometimes life finds you more than you picking it. And Mine is somewhat a story of that. I'm an architectural engineer by training, which means I focused on all different aspects of building design. I focused on structural engineering and I worked as a structural engineer after I graduated, but my background included things like passive solar design and acoustics and all these other architectural, if you will, aspects of buildings, but from an engineering perspective, right? And so when I was back in I guess it would have been in 2004 or so, when LEED first came out, I was doing consulting work in the industry, in the masonry industry, but not a lot related to green building because green building didn't really exist then. But when LEED first came out, I was approached by the masonry industry, specifically TMS, to get involved in lead and join the U.S. Green Building Council because at that time, when it was first formed, U.S. Green Building Council did not allow trade associations of any type or manufacturers to be members. They didn't want to have that manufacturer influence as part of their work in developing lead when it first came out. And so that's how I got started, really, is representing the industry and joining USGBC, and providing comments and inputs on the early version of LEAD, which was, that it's not a consensus process, so it's not like ASTM, like some of your listeners may be familiar with, but we did what we can to be informed and to have an impact there. And so it just kind of evolved from there because, of course, back at that point, it was a very new thing and it blended really well with my background as an AE because those other things like passive solar and just energy and acoustics and all those other aspects of a building, I was very familiar with because of my college degree and my training. So it really evolved from there and just grew to be a large portion of the work that I do in the industry, representing the masonry industry and codes and development, codes and standards development, and then providing training and other things in sustainability. And it's been a great fit because obviously I have an interest in those things. That's why I have that degree that I have, and so I've really enjoyed that focus.
Well, that's awesome. And we're so happy to have you on our team when it comes to spreading the good word of sustainability. And I think that we hit on a lot of points in this conversation. And I think we can continue the conversation because maybe in another episode, I'd love to have you and Jason Thompson as guests. We had him on individually talking about resiliency. And I think we could just combine the two forces and really share some different perspectives and information because I think he's a structural engineer by trade, right, Phil?
Yep.
Yeah. So having the structural engineer side and the architectural engineer side, it all comes together and we can share it to the architects of the world while they're designing. Phil, are there any other questions you have?
No, I think we hit on all the main points I was looking to get out of it. So thank you so much, Tina. I learned a ton this morning.
Oh, thanks for having me. I really enjoyed talking with you all, and I really just great opportunity to get the word out. So thanks for having me.
Well, thank you. And for our listeners, you can find us on Apple Podcasts, Google Podcasts, and Spotify. Please share this episode if you enjoyed the content, and we look forward to our next episode. Have a good day. Thank you for listening to this episode of Masonry Principles. To continue the conversation, be sure to reach out to us by visiting masonryprinciples.com.